Hello, everybody. Thank you for making it here, and thank you to the organizers of DAC for assigning me the much-coveted mid-afternoon nap time slot. If I talk really quietly, maybe all of you can have your nap. So we're going to talk about IoT because, of course, everybody does. You can't go to DAC and not talk about IoT, so what the heck, let's give it a try. My name's Jim Turley. You have no idea who I am or why I'm here, so what the heck? This is what I tell my parents. First of all, I'm one of the editors for EE Journal. Just to be clear, EE Journal is not the one that just got sold to a distributor. EE Journal is still independent magazine, thank you very much. I also run a microprocessor analysis firm called Silicon Insider, because all the good names were taken. I've written 7 books on computers and semiconductors and software. I used to run a magazine called Embedded Systems Design. I used to put on a conference called ESC. I used to have a real job. I used to be an engineer. I was a programmer, and then I was a hardware guy, and then a programmer again, and a hardware. So I was kind of a switch hitter, although you have to be careful who you tell that to. I was actually the president and CEO of a publicly traded microprocessor company for a while, wore a necktie and everything. And I did a stint in marketing for another microprocessor company, but when my parents ask, I just say, I'm a full-time nerd. This is what I do. Microprocessors, embedded systems, and now, of course, IoT. You can follow me on Twitter. You can read EE Journal. You can ask expensive questions at Silicon Insider. OK, first surprise of the day. Guess what? All life on Earth is insects. Bet you didn't know that. Seriously, if space aliens came to Earth and did an inventory of life on our planet and rounded off the fractions of all, they would say Earth is a planet of insects. That's true. Look at the bar graph here. Bar graphs don't lie. Of all the known species of life on Earth, almost all of them are insects. There are 8.75 million different identified species of insects on Earth, as opposed to a couple of hundred or a couple of thousand mammals, fungi, and whatnot. So that's true. If you round the fractions at all, there are no mammals, no virus, no bacteria, no trees, no fish, no plants, no plankton, no protozoa, no birds, no nothing. If you round the fractions at all, Earth is nothing but insects. And at this point, you're thinking, I've walked into the wrong talk. This guy's talking about something else entirely. Well, here's the payoff. The electronics world is almost exactly the same. Almost all of electronics is IoT, what we used to call embedded systems. This tiny little fraction is computers, which is what your family thinks you do. Right? Computers are a vanishingly small part of the overall electronics industry. All the rest of it is embedded. All the rest of it is IoT. All the rest of it is non-computer systems. Coincidentally, the number of computers, or the proportion, I should say, the proportion of computers in the world is equivalent to the number of viruses in real life. That's got to be some sort of cosmic joke on us. I think it just has to be. So computers are a vanishingly small proportion of the computer industry, of the electronics industry. We work on everything else. We work on embedded. We work on IoT. We work on real-life devices. So we're going to talk about that going forward. Where is this market headed? Where is the technology headed? And what do we, as developers, as marketers, as engineers, and debuggers, what do we have to look forward to working in this business? Well, for this talk, I rely on my 2 fallback sources, my 2 main sources of inspiration when I was an engineer, and that is Bender Rodriguez and Battlestar Galactica. We'll get to those in a minute. 2 important lessons going forward. First of all, another factoid. Did you know that transistors are more plentiful than grains of rice? Wow. Rice. Rice is the staple that feeds half of the people on this planet. Rice is as low-tech as you can get. Anybody can farm rice. All you need is a swampy field. Rice grows wild. Rice grows with no attention at all. Rice is as low-tech as you can get, and it's shipped in tons. I mean, millions of tons every day. Rice is everywhere, and yet semiconductor transistors, little submicron transistors that we work with all the time, which are one of the most complex things humankind has ever created. Semiconductor transistors actually outnumber grains of rice. Two opposite ends of the tech spectrum, totally natural, totally unnatural. Which one do you think would be the most common? Transistors. Wow. So we live in a world where transistors are more plentiful than grains of rice, which means we're at a really interesting point in human history. And I know that always sounds really pretentious when people say that. Oh, we're at an inflection point. We're at a knee on the curve. Baloney. When a businessman shows up the PowerPoint slides that says we're at an inflection point, throw that one away. That just means he's selling you something. But as far as I can tell, this is the only time in human history where our ability to build is better than our ability to design. Think about this for a minute. We've always been able to dream up things that we can't make, right? We've always been able to dream up tall skyscrapers that you can't actually build. We've always been able to imagine bridges that are impossible to build. We've imagined time machines that so far we don't know how to build, spaceships that we don't know how to build. Throughout human history, we've always imagined things that we can never build. And yet, in the electronics industry, we have the opposite situation. We can build things we can't imagine. Our ability to construct transistors, to construct circuits, to construct wafer-scale integration exceeds our ability to wrap our heads around the design. It's the only time in history that I can find that our ability to build, to manufacture, has outstripped our ability to design. Wow. Which is, of course, why we're all here. What do we do about this? What do you do when you are presented with an embarrassment of riches? What do you do when there's too many Lego blocks in the pile? Well, we have a couple of choices. Evolve your job skills or get out of the game. Maybe. Or retire. So I see a couple of choices. Because our products get smarter and we don't, something's going to have to give. Our products get more complex, smarter all the time, and yet we're still basically the hairless tree apes that we always were. So we either need to evolve our job skills, or we have to somehow dumb down the design process so that we can wrap our heads around the design. Now, we can do that through better EDA tools. We can do it through more reused IP. In other words, just borrowing other people's stuff rather than designing our own. Or some other method to try to wrap our heads around this ever-increasing complexity. Now, there's a third option, if you're up for it, and that is you can go into marketing. Right? You can basically just punt. You can say, you know what? This is too hard for me. I'm not going to do engineering anymore. I'm going to go into marketing. So, it's fine. It happens. I did it. Lived to tell about it. So there we are. Those are your choices. Which brings us to Bender. And in the words of the great Bender Rodriguez, we're boned. We are. We're in a bad situation. We're in a tough space. What are we going to do about this? Well, let's see. And the reason I think we're in a tough spot, the reason I think we as circuit designers are basically boned, is security. I think security is the biggest problem facing us. And the first half a dozen times I heard someone tell me that, I blew them off. I said, I don't think that's true. I think we have much bigger problems to deal with. There's power consumption, there's EMI problems to deal with, there's the rise of photonics, there's any number of technological changes you could think of that could potentially complicate our job. And those are all real things, and all the people around us here are trying to help us figure those out, and that's great. But the big one, the one I think we're really going to have a tough time with, is security. Securing our little gizmos that we design so that they don't get hacked and they don't get used against their customers or against us. Why do I think this is a problem? Well, let me try to sell you on this idea. Or let me try and convince you, at least. I think of security and cryptography and those sorts of issues the same way I think about debugging. Right? You remember debugging programs or debugging hardware. I see debugging, whether it's hardware or software, I see debugging always goes in two stages. Right? The first stage of debugging a program or debugging a circuit is getting it to do what you want. Right? Piece of cake, right? That's obvious, Jim. We know that. So the first stage is trying to get your program to say hello world. right? And oops, it accidentally prints garbage because you didn't do the ASCII encoding right or something. So, you debug the program until you get it to do what you want, or you debug the circuit to get it to do what you want. Okay, that's stage 1 debugging that we all know about. And then there's stage 2 debugging, which in my experience is always a lot harder, and that's getting it to not do the stuff you don't want. Oh, whoops, my Hello World program finally works, but it tips over at midnight on New Year's Eve. Oh, I didn't anticipate that problem. Or it works on a 16-bit machine, but not on a 32-bit machine because I was stupid about pointers, or I didn't, cast my integer properly. Or my hardware fails because there's a welding shop next door. And I actually had this happen once. I was debugging a big honkin' mini computer. They worked great in the lab. We shipped it to the customer. It works great for like a week. And then the system would tip over. It would crash, usually on a Friday afternoon, every week, like clockwork. We couldn't figure it out. We finally went to the customer's site. We're hooking up oscope probes and logic analyzers. We're trying to figure it out. We're running all of our diagnostics. The machine's perfect. It works fine. And then sure enough, right in the middle of Friday afternoon, it fails again. There it is. We can't figure out why. We debugged this for a couple of weeks. It turns out the office next door in the business park was a welding shop. And about 3 o'clock on Friday afternoon, they fire up their arc welders to do some welding, and it sent such nasty AC spikes through the AC line that it crashed all the digital equipment. It had nothing to do with us. How would we ever have anticipated that? Who can ever see that coming? One of the projects I worked on was debugging one of the hardware systems in the TGV, the French bullet train. And man, you talk about EMI problems. This thing is a huge magnet. It's a humongous freaking electromagnet that moves at 100 miles an hour. I had no idea how to deal with problems like that. That's not something they ever train you for. So stage 2 debugging, the second stage debugging, either for hardware or software, is the hard part because you have to anticipate all these things you never would have thought of. What happens at midnight? What happens if the sky is covered by clouds? What happens if someone hits it with a hammer? You know what that's like. How do you anticipate those problems? Well, that's the easy part. Because security is like that plus a whole third level of now you get to anticipate security problems that you have no experience with, and that I have no experience with, and the people in your lab have no experience with, and nobody in your support forum has no experience with. So now we have to fix problems that we barely even understand and have never anticipated and are completely, frankly, unequipped to deal with. How do you deal with malformed network packets that come into your new connected device? How do you deal with a security algorithm that you licensed but has bugs in it? You didn't know that. How do you deal with bad certificates? How do you deal with actually malicious hacking? Most of these problems aren't even malicious. They're just accidental. We still don't know how to deal with them. So security is like debugging, but way worse. And the other problem, or the other difference between security and debugging is that we're not good at it. This is not something we've ever been trained for. Securing a system, even a system that you designed, means looking for problems that you're not accustomed to locating and fixing them in ways that, frankly, we don't understand how to do. That's not our skill set. It's not our background. We don't even know what to look for. I wouldn't hire a plumber to debug my code. He's got great skills, and he makes more per hour than I do, but he doesn't have the right skill set. So in the same sense, your typical programmer, your typical software engineer, your typical hardware developer, your typical chip designer doesn't have the kind of background to go looking for security bugs. So what you're really going to do, aren't you, is you're going to poke at it a little bit, you're going to dream up a couple of security scenarios, you're going to fix those leaks, and then you're going to tell your boss, I did it, I'm done, it's secured now, and hope the product gets shipped really quickly before you fix it. But this is not stuff we have experience with. This is not stuff we know how to fix. And then the bigger problem is not only experience, because you can always gain experience over time, right? That's what happens when you do things wrong, you gain experience. Is the insidious thing about security is you will never know when it's right. And you won't ever know when it's wrong. And this is wholly unlike hardware and software debugging. If your hardware fails, you know it, because you know what it was supposed to do. You designed it to do something, and you can tell straight up, yes, this works, or no, it doesn't. Same thing with your software. You know if it works, or you know if it doesn't, because you created it, you can test it, you know if it works. With security, you have no idea, and you never will. This is not an issue of an experience. This is inherent to the problem of security. The bad guys won't tell you that there's a security hole in your problem, will they? They're not going to phone you up and say, hey, guess what? Well, they might actually, but they're probably not going to phone you up and say, hey, we found a hole in your new widget, in your new Nest thermostat. Hey, we found a hole in your Lexus entertainment system. Did you guys read about this? Lexus, which is, of course, a Toyota with leather seats, they just discovered that they just downloaded a firmware update to a whole bunch of gullible Lexus owners, which I repeat myself, and they bricked the entertainment system. Oops. We can't get it back. There were apparently bugs in the firmware download. The whole glass dashboard, the whole infotainment system, the map, all of it's gone. And we can't fix it with another over update because it's bricked. So we're pretty sure you're going to have to drive it into the Lexus dealership and have us either yank the whole thing out or plug in an umbilical and fix it because we goofed up the over-air firmware update. And that was from the factory. These were the good guys. If the bad guys do it, what hope do you have? So like I said, security is like debugging, but worse, because you will never know where the problems are. You will never know if the security holes are fixed because nobody's going to tell you. And if you do find security holes, either through dumb luck or your own expertise or because you've hired some white hats to poke at the system for you, you still won't know if those are fixed, right? Because the first rule of debugging, right, is just because you found a problem doesn't mean you found the problem. We all learned that in Engineering 101. Just because you find a bug doesn't mean they're all gone. Same thing with security. Even though the white hats might have found a security hole and you've patched it and you pat yourself on the back and tell your boss, that doesn't mean you've got them all. And you will never know. Unlike hardware or software debugging, you will never know. And this is what makes security creepy. And that, of course, brings us to Battlestar Galactica, naturally. Not the really old series from the 1970s, which was terrible, but the reasonably new series from the last decade, which was actually reasonably okay. If any of you nerds remember the very first episode of Battlestar Galactica, there's a very short but also very important scene where someone from the spaceship is walking down the corridor with a journalist explaining the technology aboard the Battlestar Galactica. And in 2 sentences, he sets the stage for the whole series. He says the reason we don't have high-tech computers or networks aboard the Battlestar is because we're worried about Cylon invasion. And that very quick scene answers 1,000 questions, because here we have a freaking starship. We have guys who fly spaceships. We have laser cannons. We've got all this high-tech stuff, and yet there's no computers anywhere to be seen. They don't even have cell phones in Battlestar Galactica. There are no computers and no networks, and this turns out to be a really important plot device because the guy on the ship is exactly true. The reason we don't have these computers and networks is because we're worried about viruses. We're worried about infiltration. We're worried about hackers. And in the world of Battlestar Galactica, they're worried about Cylons. And so even back then, or maybe into the future, whichever, they were worried about security, and they knew that that would be a security hole that they could never, ever fix. And so that turns out to set the whole stage, as I said, for Galactica and why this supposedly high-tech ship has no computers on it. Okay. The other problem with IoT, Internet of Things, embedded devices, connected devices, and security is that once you start connecting to the world, once you put that Wi-Fi interface, that Zigbee interface, that Ethernet interface, that TCP/IP stack, once you do all that, and you transition from the world of embedded to the world of IoT, you are now debugging everyone else's problems. Because by definition, you are connected. You are part of a network, even if it's a small one. But you're probably indirectly connected to the cloud in some sense and so on. That's the point, right? Which means everyone else's communications is now your problem. Everyone else's data packet is your problem. Everyone else's hardware interface becomes your problem. Everyone else's TCP/IP stack and IPsec and everything else becomes your problem because you're going to be communicating with devices that you didn't create, you didn't design, and you have no control over debugging. So you thought debugging your own device was hard. Now you get to debug everyone else's interface too. Oh, joy. And it's exactly those other devices that are going to cause your problems, because God knows you're good at what you do. It's that other guy who's a bozo. So So you get to not only fix bugs with your own hardware and your own software, but you get to fix interface problems with hardware you've never seen before, hardware you may not know anything about. Something to do with the cloud server, you know, maybe it's Amazon's problem, maybe it's your provider's problem, you don't know, but you have no control over it. Lucky you. In your connected device, whether it's a thermostat or a cell phone or a factory robot, whatever gizmo you're creating, imagine the disruptive bugs that are going to happen through someone else's interface. Imagine what happens because someone sends you a malformed packet, because someone that you have no control over screws up the security, because they have a bad password, because their system got hacked, because their users are bad guys. The list goes on and on and on of all these things that can go wrong that are out of your control. You get to deal with it now because you have a connected device. And you're working with amateurs. Now, you're a professional. You've got the certificate on the wall. You've got the little plaques. You've got the raise from the last project that you shipped on time. You're good at what you do. That's why you're here. But those other guys, complete bozos. Complete bozos. Because they're doing their first IoT design, right? Maybe they've been designing thermostats for ages. Maybe they've worked for Honeywell for 3 generations. These guys have thermostats in their blood. But this is their first IoT thermostat. This is the first one with Wi-Fi. Woohoo! And so they hired somebody to add Wi-Fi to their thermostat. And it's their first one. And it works. It passed their test. It went through stage 1 debugging, right? Does all the things we want it to do. It went through their stage 2 debugging. OK, we don't think it does anything we don't want it to do, so they ship it. And now it's talking to your device because it's on the same Wi-Fi network, or at least it's close by. It's within a couple hundred feet. And you get to find out that they screwed it up, that maybe their Wi-Fi is chattering, or their wireless interface, their 802.11 interface is chattering a little bit too much. Maybe it's not very good about checksums. Maybe it's sloppy with passwords. Maybe it's sending unencrypted data when it should be sending encrypted data. All this stuff contaminating the airwaves in your airspace, you get to deal with this because you're dealing with a bunch of amateurs who are getting into the IoT market for the very first time. Lucky you. And do you think that guy who designed his very first Wi-Fi thermostat, do you think he's going to delay shipping the product? Because maybe it's not quite right yet. Maybe the Wi-Fi interface isn't quite bulletproof yet. Do you think they're going to delay shipping just to make things better? Would you? Would your company do it? Would your boss do it? Not any place I've worked. Hey, we passed stage 1 testing, passed stage 2 testing, ship it. We're going to put you on a new project. Hooray, now it's tech support's problem. The design engineers are off to something else. So you say, OK, this is all great, Jim. I kind of understand what you're telling me. The good news is this doesn't apply to me, because I don't make thermostats. I make farm equipment. I make elevators. I make industrial robots. I make fill in the blank. Everybody fill in the blank. OK, that's what you make. And you follow it up with, so we don't have to worry about that. Security is not my problem. Because I'm not making a high security server that's going to be the target of an attack. I'm not interfacing with Amazon AWS. I'm not a juicy target. Nobody's going to try to hack my stuff. My stuff's not interesting. I just make elevators. I just make, you know, whatever it is. And so I'm not going to be the target. And that's precisely the opposite of the truth. It's precisely because your device is small and uninteresting and unobtrusive and low-key, it's precisely because of those things that you are going to be the first target. Where's a hacker going to start? He's going to start with the weakest link. He's going to start with the least secure system on the network. He's going to start with the easiest target. And because you just admitted that your device is the smallest, lowest tech, most insignificant one in the network, in the cloud, you pretty much identified your own device as the place where he's going to start. You are going to be the entry point. You are going to be patient 0. Because let's say you are building thermostats. You've got a whopping 64K of ROM or something like that. you don't have a lot of firmware space to put in a lot of security measures. So you're, frankly, not going to have very advanced security. Well, and you think that's all right, because I'm a simple device, I don't need advanced security. But I say just the opposite is true. Because you have a simple device, you need the best security. Otherwise, you're going to be the entry point to the network. And it's going to get from your device into the next device next to you, which is probably better designed, but trusts you because you're part of the same network. And then it's going to go from there to the next one, to the next one, the next one, to whatever the actual target really is. And so just like any kind of infiltration, just like a Mission Impossible movie, just like a Jason Bourne movie, you sneak in through the unprotected back door that nobody's paying attention to, and through the air ducts, and down through the ceiling, and so on until you finally get to the crown jewels in the middle. So it's exactly these low-key, low byte count, low bandwidth, low cost, low profile devices that are going to be the most at risk. And it's precisely because we don't expect it. Just like the Spanish Inquisition. We never expect it. Okay, my favorite example of firmware hacking, that one right there. And I'll notice, I just like the picture. That's probably exactly what I would have done if I figured out how to hack highway signs. And I noticed they left no blank spaces. My theory as a firmware programmer is that he filled the blank spaces with exclamation marks because he didn't figure out how to blank the text that used to be there before. Right? The message probably would have shown through otherwise, so you got to fill all the spaces. So some good examples of hacking, and then maybe some worse examples, some things that maybe, frankly, I wish I hadn't designed. Remember that pie chart at the beginning where virtually everything is an embedded system? That means there's a whole lot of embedded systems out there, and some a little better than others. This is my microwave oven back at home. It's made by a company that we won't name, but it rhymes with Whirlpool. It has a button on it labeled Add Minute. Anyone want to guess what that does? Come on. It adds 30 seconds. Yep. So I pointed that out to an English major friend, and he said, maybe it's really add minute amount of time. I'm sure that's what they were thinking. At the opposite extreme, we have this new device. I checked the show floor to make sure they're not exhibiting today because I didn't want to annoy them. This is from a new company called Cube. It's an internet-connected garbage can. Honest to God, I'm not making it up. Check it out. It's Cube. It's internet-connected garbage can. It's an IoT recycling bin. It has weight sensors. You get to figure out why. A temperature sensor. You get to figure out why. A humidity sensor. You can probably guess that one. A presence detector. I had to look this one up. Whose presence is it detecting? Mine or the garbage? Turns out it's mine. Okay. A 4.3-inch screen like any good cell phone would have. Battery autonomy of 21 days, which means after a month you have to plug this thing back in to recharge the battery. I thought it'd be really hilarious if these were disposable batteries and you just like took them out and then put them back in. It's like, wow, that really is recycling. Wi-Fi and USB and, of course, RFID tags. What's the point of this product? The idea is it has weight sensors and humidity sensors so that it knows when it gets full. Woohoo! And then, of course, there's an app that goes with it because God knows there's an app that goes with everything. So yes, your garbage can will actually notify you via iPhone app, hey, your recycling bin's full. Or, hey, the battery's dying. So, yep, this is probably one of the worst examples of an IoT device that I could possibly think. But God, it looks pretty, though, doesn't it? It's really nice industrial design. This one's actually kind of cool. This is from a company called Anodo, and it's a smart pen. It's basically a pen that has GPS, and I don't mean literally GPS in the sense of satellites. What it does is if you write on special Anodo-branded paper, it knows what you're writing, because it can detect its position on the paper. Now, when you look at it, like in the example, they draw a letter A, the pen knows you've drawn a letter A, and then it can upload it to your tablet or upload it to your computer or whatever, which I suppose could be really handy for note-taking. Or if you're a graphic designer, you can sketch on the paper and pencil, paper and pen, and it'll upload that to your laptop. Okay, you know, I can kind of see that might be interesting. But the way it works is really cool and really insanely complex, and that is you have to buy special paper from Anodo. And the paper has a very small, almost impossible to see pattern of dots on it. And the dots look random, but they're not. When you hold the pen down close to the paper, the pen can see about 10 or 15 of the dots at once. And from the 10 or so dots that it can see, it knows exactly where it is on the paper. So it doesn't matter whether you actually have ink in the pen or not. All the pen wants to know is that you've moved it around. The ink is for you. The little pattern of dots is for it. And so they had all these cool ideas, like I said, you could sketch notepads and they'd be uploaded to your computer. Or you print a catalog, right? Everybody remember those? You print a catalog and you took this pen and you could just circle the item that you want and your computer would know. And it would order it from Amazon for you or something like that. So the technology is pretty cool, actually, and really complex. But the problem is you have to buy special paper. And everything you print on it has to be on that paper or the whole system falls apart. So the whole thing seems like a lot more trouble than it was worth. The company is really proud of pointing out the fact that their pattern of dots is so elaborate and so accurate that they could actually spread paper over half of the continental United States and the pen would know exactly where it is. It's, like I said, GPS for pens. Okay, moving on, there's a company in St. Paul, Minnesota called Destron Fearing, and they specialize in something they call animal identification tagging. Well, I already know what animal that is. It's a cow and a dog. How hard was that? But their literature is great. I have to look this up here for just a second. And they say, you know, this is when you chip your dog, so if your dog gets lost, you can find her again. You have them for cows and whatnot. So they identify themselves as a developer of syringe injectable miniaturized microchip technology. And at the bottom, you can see here they've apparently developed a version that helps you find loose change. And then there's also a version that went up in space. It went in John Glenn's intestines. He swallowed it, and it monitored his health while he was in space before the probe was, shall we say, ejected. And there's a picture of it there next to the thumb. But the literature that goes with this stuff is great because they say it's for space shuttle astronauts, which seems like a really small market for me. Space shuttle astronauts, Mount Everest climbers, and Australians. Something about Australians we need to know? Sadly, the military is losing out on buglers. So if you look closely at the bell of this trumpet, you'll see there's an electronic device in there, which is basically a canned recording of taps. And so what the bugler here is doing is he just puts it inside his trumpet, hold it up, press the button, and stand there and pretend to be a bugler, and it plays taps for you. The reason this was invented is because, according to a Pentagon spokesman, we're losing veterans faster than we are training new buglers. And so we don't have anyone to play at military funerals, so we have an electronic device for it instead. Here's a patent. You've all seen patent applications before. I bet you haven't seen this patent application before. This is for a personal electronic device, and I emphasize the word personal because if you can't read the small print, it's for a force-sensitive sound-playing condom. And one of the claims in the patent says it contains a chip-controlled piezoelectric sound transducer, which, and I quote, plays a melody or voice message when activated. Voice message? What, like your mother's voice? What would you possibly use that for? Here we have a somewhat more underage example. These are two little devices called the Love Getty. And despite the disturbingly underaged models, the idea is that you buy one for yourself, you program it with your particular likes and dislikes, and then you keep it in your pocket. If you come within proximity of another person with a Love Getty who has programmed in compatible characteristics, the alarm goes off to let you know that your life match is nearby. And then you two get to locate each other. There's a blue version and a pink version. There's also a third version called the Gay Getty, which does exactly what you would expect. I can't imagine there was a huge market for these, except, you know, perhaps an embedded systems conference or DAC. In kind of the same vein, there's another company that's produced this translation device called Bowlingual. It's pitched as a translator for dogs. Well, actually, it's a translator for their human owners. It's supposed to translate dog messages. And according to the literature, it knows 173 different phrases. I didn't know my dog knew 173 different phrases. But yep, you put it near the dog, and when your dog barks, it translates for you, and it shows the display in English on the little display. Now, I say English because the small print down at the bottom says, "For sale in the USA only." And I'm thinking, why? Is there something about American dogs that are easier to translate than dogs in the rest of the world? Or more likely, is it Americans are more gullible than other dog owners around other parts of the world? Maybe just the firmware is only ready for US English translation, but I'm not entirely convinced. Here's a good use for DSP chips as an audio filter. We've all seen audio equipment that does, filtering and adds reverb and other kinds of cool things. Well, this is a DSP chip that removes foul language from movies. This is like a Amish DVD player. Imagine programming the firmware for this thing, right? How do you test it, right? We're going back to the 3 stages of firmware test. How do you test that this works? And how do you know when it's done? Anyway, that had to be fun. But yep, you can buy a Sanyo DVD player that filters out the movies. I'm thinking, depending on the movie that you put in, it might filter out almost everything, right? Put in a Quentin Tarantino movie, and all the actors look like they're in a Japanese monster movie, right? Their lips move, but they're not saying anything. And if you're into audio equipment, and really who isn't, it's fascinating to look at some of the stuff that electronics engineers have come up with for gullible audio files, which of course is redundant. And this is one of my favorite. You have to identify what this box does based on the literature. I'll read it to you in case you can't read it. 2 isolated circuits, each one with 1 level of quantum mechanical filtration. They're caps. Networking along with the RFI and the surge and spike protection of the input circuitry, the internal elements are housed in an anti-resonant oak chassis. Ooh. And filled with damping and heat-absorbing materials. Sounds like newspaper. The internal wiring is also damped, and then it goes on to talk about how the damping was developed, yada, yada, yada. The box at the top, these are 3 different products. The box at the top costs $5,000. It's a power strip. It's exactly what it looks like. You plug the AC into the wall, and then you plug your expensive stereo equipment into the top. It's a $5,000 power strip for audio files who never studied electrical engineering. The smaller device in the middle with the RCA jacks on it, $2,500 a piece. And of course, you have to buy 2 for each speaker. So $5,000 the pair. And it apparently straightens out the ions in your speaker cable. What I didn't show here is they also sell directional speaker cable. Because God forbid you should hook your speaker cable up the wrong direction. What makes it directional, I wondered? Is it the copper or the gold or whatever? No, that's way too obvious. It's spiral wound, like most lamp cord speaker cable is, and apparently it's important whether the sound travels down your wire in a clockwise spiral or a counterclockwise spiral. I had no idea. This is what happens when you skip that day in electrical engineering class. So see, these are the real opportunities for engineers. Develop this stuff, sell it to audiophiles who have no idea what it does. So to finish up, we have a lot of problems to deal with. It's a complex system. In a situation like this, you have to wonder, how often do they collect the fine? But I know that ultimately you will all do the right thing and carry on with your engineering careers. Thank you very much. My name's Jim Turley. I work for EE Journal and Silicon Insider.